Okay, so welcome everyone. A brief recap on our previous class, which we treated Prisma and Prisma clients. We learned about Prisma clients, and also we learned about migrations. We also demonstrated with some examples and all of that. So in today's class, we try to understand Docker. So most of us, we already know what Docker is, and some of us really don't know. So in our today's class, we will try to understand what Docker is all about. We learn about VMs and containers. Then we learn about their differences.
Recording in progress.
We learn about their differences as well. Basically, we jump into Docker, its uses and importance as well. We learn about the Docker components, the Docker basics, and the Docker images. So Docker on its own is it's a complex thing. So saying we will learn all about Docker in just a day is impossible. But I've selected the key topics. So we try to understand the key topics, and then from there you extend your search and then break down the subtopics and try to understand everything. So after the Docker basics, we also try to understand what Docker images are and how to build images, basically using the command line or the Docker file. And from here, we also learn about Docker file instructions and all of that. So that is much to learn in a day, not even a day, in just 2 hours. But so let's get started. So we'll start with virtual machines, followed by containers, and then the difference between virtual machines and containers. So I sent you something in the group yesterday to learn about virtual machines, the different types of virtual machines, and also what again, and all of that. So you should learn about the NVMEs and the standard virtual machines. So what really are virtual machines? Okay, so a virtual machine is a computer software that runs inside of another physical computer. So let's say it acts as a real computer with its own CPU, memory, storage, and operating system. But instead of its physical hardware components, it uses the resources borrowed from the host machine. Okay, so let's say I have a virtual machine here. So I want to isolate some resources. Like I want to build a software, but I don't want it to run on Mac OS, on this operating system, the host machine operating system. So this is Mac OS. So I want it to run on, I want to use either Ubuntu or I want to use Windows. So I will simply install a virtual machine, or I will install a hypervisor that will create a virtual machine for me, and then I will install Windows on that virtual machine or the Ubuntu, and then decide and then try to work on that virtual machine without having to use the Mac OS on the host machine. So VMs are created and managed by a software program called a hypervisor, as I earlier mentioned. So the hypervisor acts like a traffic controller. So what it does is it divides the physical computer resources among multiple VMs. You can have up to like 2, 3, 4 VMs, depending on your system, your host machine's capacity. So you can create a VM to install Windows operating system. You can create another VM to install Ubuntu and then run different software there. So you can start up a VM, and then we have different type of VMs. We have HyperKits, and then we have this other one. I've actually forgotten what is its name. It's called HyperKit is a light one for macOS. And then we have the benefit of VMs is you can run multiple operating systems. This is one of the benefits of VMs, virtual machines. You can run multiple operating systems. So you can run a Windows virtual machine on a Mac, or a Linux virtual machine on a Windows machine. So resource efficiency as well. You can share resources between these VMs. So VMs allow you to like consolidate multiple applications onto a single physical server, saving a hardware cost. So you can have only one hardware running. Let's say, for example, you can have a single hardware running 3 to 4 computers. So there's a physical machine, but then the other computers are just virtual machines on top of the same hardware. And then we have also the other benefits is isolation. So virtual machines are isolated from each other. So a problem in one VM won't crash the others or the host machine. So if one virtual machine has a problem, the host machine or the other virtual machines won't be affected. So that is isolation. And then portability. So virtual machines are easily portable between different physical machines. So now that we've understood the basics of virtual, I don't want to go in depth. I don't want to start talking about the types of virtual machines, how to boot or how to install and then start the virtual machines on all of that. I just want you to know that there are virtual machines and then there are containers. So try to understand containers, then we compare and contrast between virtual machines and containers. So what are containers? So now that we've understood the basics of virtual machines, that they are just virtual computers inside of the host computer that you can create multiple machines. You know, your computer is a machine. Your computer is a physical machine, but in that case, where a machine doesn't have any hardware, it's running on the host machine, which itself is a physical machine. That machine becomes a virtual machine. So we install a Mac OS on a Windows using the hypervisor to create a virtual machine, and then installs that Windows on it. That machine with that operating system automatically becomes a virtual machine, because you can actually on your physical machine, which is Windows or Mac, and then boot a virtual machine on the Mac on the Mac or the Windows, which is the host machine, then boot another virtual machine, and then decide to use the virtual machine, completely avoiding the host machine. But that virtual machine is still using some resource. You can allocate, if you have 8 gig of RAM, you can decide to allocate 2 or 3 gig of RAM to your virtual machines, or you can write there's a setup that you can, there's a config file that you can decide to set. Okay, I have 4 virtual machines, so each virtual machine should consume 1 gig RAM from my physical machine. If my physical machine has 8 gig of RAM, and I boot up all these 4 virtual machines, each should be allocated 1 gig RAM. So my virtual machine will be, my physical machine will be left, the host machine, which is also the physical machine, will be left with 4 gig of RAM, which the 4 virtual machines will be allocated 1 gig RAM each. And then you can decide to, okay, now the storage on my system, I have 500 gig. So each virtual machine should be allocated 100 gig. So we have 4, then your physical machine will be left with 100 gig, and then the rest will have 100 gig each. So each time you short your virtual machines, the space will be freed for your physical machine to take control. Okay, so that's basically it. But in case of storage, if you have things in your virtual machines, that space will not be freed, because you have things you stored there, and then those things we use those that space allocated by 100 gig to store things. But then the RAM, it's only what, you know, RAM is a volatile memory kind of storage, because anytime you shut down your system, the space is freed. So anytime you shut down your virtual machine, the RAM will be free to your physical machine to take control. So that's basically it. So what are containers? Okay, so containers don't virtualize the entire operating system. So they are like virtual machines, but they don't virtualize the complete operating system. Instead, they package an application's code, its runtime environment and configurations together into a standard unit. So this unit is called a container image. So let's try to understand what a container is. So when you think of a VM, it's like a whole separate, let's use like a kitchen, for example. It's like a whole separate kitchen with its own stove, oven, fridge, and every other thing you need to prepare a meal, or you need to prepare a recipe, something like that. But when it comes to a container on the other hand, is more like a pre-made recipe with all the ingredients and instruction needed to prepare the specific dish. For instance, you want to cook some egusi soup. So a container is it's a pre-made recipe, like there's pepper, there's everything, and the meat and everything you need to prepare that egusi soup. So once there's everything, all you need to do is to bring all those things together, then follow the process to create that dish. But then in case of a virtual machines, all those things are still, and a virtual machine has its own um, electric cooker or gas cooker, and has its own fridge and every other thing needed to prepare any kind of recipe or dish. But when it comes to a container, they are pre-made, and then you don't have to think of it as a whole kitchen, but it's just a portion where everything is being kept for you. Just take it and then prepare this meal, something like that. So when it comes to benefits of containers over virtual machines, containers are lightweight and portable. So containers share the operating system kernel of the host machine. So it makes them much smaller and faster to start up than VMs. So this also allows them to be easily moved between different environments. So consider application, you can also consider application behavior. So since containers include all the dependencies and every other thing needed to package an application, so you can run an image. You can just take the image and then run it on any machine without having to worry about the runtime or anything, because that is a container, and anywhere you place it and then run it, that's an image, and anywhere you place it and run it, it becomes a container, and then you don't have to worry about the behavior or any other thing, because that environment is within that image and nothing will change. You are just running that container on top of another machine, and you don't have to worry about the behavior or any other thing about that container. And the resource efficiency. Multiple containers can run on a single machine, because you don't have to allocate RAM and all of that, but it depends on what you're running on that machine. Multiple containers can be run on a single machine. So multiple containers can run a single machine, sharing the host resources more efficiently than VMs. A VM will have to, contain its operating system. So, the storage and operating system we consume. So, but a container doesn't have to go through all those processes. You just package it in an image, and then that's all. An image is very lightweight, and except you run it. When you run an image, it becomes a container. So, let's say an image is just a software, an executable that you install on your machine. Then that is an image. So a container is like a process. Okay, let's say, a process is a running software. You have a software on your computer. When you run it, it becomes a process. So if you run two instances of that software, it becomes two processes. So a container is like a process. When you run an image, it becomes a container, and a container is like a process that's a running software. So that is basically what a container is. And we'll look at containers in depth as we progress. So how containers differs from VMs is resource isolation and startup time. So containers share the kernel, while VMs have their own isolated kernels. You don't know what a software kernel is, or a machine. No, I don't want to go into this. We don't have that much time. So as I mentioned, containers share their own kernel, while the VMs have their own isolated kernels. Every operating system on a machine has its own kernel. So a VM has its own operating system running separately from the host machine and all of that. So it has its own kernel. But containers they run on that very machine, on the host machine. Okay, if you run the container on your system, It doesn't have its own operating system. It's running other operating system, but it has its own resources and everything needed to run its software. So the startup time, containers are much faster to start up than VMs. I agree with that, basically. Yes, but when you look at the NVMEs, they start up in let me say in microseconds, not nanoseconds, but in microseconds. They start up in microseconds. So Docker is a popular tool for building, managing, and running containers. As we continue to progress, we will explore how Docker uses container images to create and run containerized application in the next steps. So let's, now that we've understood what virtual machines are, what containers, and the difference between VMs and containers, let's proceed. And let me restate this. The main difference is resource isolation and startup time. So in resource isolation, we talked about containers shares the kernel with the host machine, while VMs have their own isolated kernels. And the startup time, containers are much faster to start up than VMs. And then you can extend your search from there. So moving on, we just explained, and then we discussed the difference between virtual machines and containers. So now let's talk about Docker. So Docker doesn't have a single definition. Basically, what Israel. Okay, let me just answer your question before moving on. We are not going to talk about Kubernetes in this class. I will just touch it a bit, but Kubernetes is way more an advanced topic to talk about in this topic. It's where it's more used by these DevOps engineers. So Kubernetes is used to orchestrate containers. Okay, since you asked this question, let me just use like 2 to 3 minutes to explain what Kubernetes is all about. So I talked about microservices in one of our previous class. So I talked about having, let's say you have an application. Let's assume the application we built, that mini application will be the casing notes. So we have 2 services, the authentication service and the node service. So we can decide to decouple that application and then make it 2 different services, like 2 different applications. The authentication would be a separate application, not knowing if the node service exists or not. So the authentication would be a separate service, and then the nodes also would be a separate service. So there will need to be a communication channel between the authentication service and the node service. So how do they communicate? And let's assume there's what we call load balancing. So where orchestration comes in is you want to have 4 instances of let's say one of your instance handles those 1,000 connections. So you have 1,000 people visiting your application to authenticate. And then when it exceeds 1,000, the load is too much for your application. So you will need to create like 3 instances of that application, like your service, the authentication service, to handle 3,000 people trying to authenticate. So when the first instance has about 500 people trying to authenticate, it will try to forward the rest, or this what we call, Robin. There are algorithms governing this. So there are some algorithms that we try to, when the first visitor visit the first server, let's say the instances are 3, let's say 3 services running on 3 different servers. So when a visitor visits the first server, the second one will be redirected to the second server, and then the third one will redirected to the third server. So the fourth one will come back to the first server, the second one will go to the second server, and the third one will go to the third server. So when you authenticate, now there will be a medium where the authentication service will tell the node service that, okay, this person is authenticated, so allow him to create a node or edit a node with his own ID. So that is where Kubernetes comes in. Kubernetes comes in, it allows you to use YAML files to write commands that when these commands are issued, it will orchestrate your containers. You have you have an image of the authentication service and the one for the node service. So Kubernetes, you say, okay, create 5 instances of this authentication service and then create 6 instances of the node service. So Kubernetes will create all of these and then they will have an IP address. So that is where this is what we call, when it comes to databases, we have a master slave architecture. So we can use this what we call database replication and database sharding. So we can use this to replicate our database. And then we have one primary instance, and then we have secondary instances. So the primary instance will be the one to be written to. Every write, so okay, let's say if you want to update or you want to create, it will be done using the primary instance. But immediately you write or update your records in the database, they'll be replicated to all the other instances. Let's say we have one primary instance and then we have 4 secondary instances. So once you write data or update data in that database, it will be replicated to those other 4 instances so that the read action will be redirected to them. So if you want to read data, it will be redirected to those secondary instances. And the reason why this is because you cannot be writing to different instances. You need to write to one, and then one will be, the data will be replicated to all those other ones. So when the primary instance goes down, one secondary instance will be promoted to become the primary instance until the primary instance comes up. Once it comes up, the other secondary instance was promoted will be demoted to the secondary instance, and then the primary instance will take over. So Kubernetes try to orchestrate it and then make them communicate within the environment. That is called a cluster. So it will create a cluster and they orchestrate all of these with the network communication and all of that. So the application will have only one IP address where external traffic will be redirected to. When you visit, let's say, www.google.com, it will take you to their homepage. Okay, that is the public IP address. But then Kubernetes is orchestrating this thing that inside of your application, you have different services. So those different services have to communicate with each other. So if service communicates with nodes, that communication should be internal and it shouldn't be outside so that hackers or any other person won't get access to your application. So that is how Kubernetes orchestrates all of them. That is just an example to try to let you understand how Kubernetes works. Because with only Docker, you have containers running. You have like 20 or 30 containers. So how do you connect all those containers together to communicate and then share information? Or let's say you want to replicate, you have a database, a database service, like the super, what is it called again? The Neon and all of that. So that is how basically, that's how it works. So what were we talking about? We're talking about the Docker. What is Docker? So Docker is a concept of containers that provide a platform for developers to easily build, share, and then run applications. So here we have different components of the Docker. But first of all, we'll talk about Docker uses the client-server architecture, and you will know what the client-server architecture is. For example, when you build an application that has a front end and a back end, then the front end is the client and the back end is the server. So any user will visit the client end and they issue commands, and then the client will forward those commands to the back end. The back end will process it, like fetch some data from the database. We have an application server, and then we have a web server. So we don't need to go in depth into explaining what an application server is or a web server is. But then your web server will basically make a request to your application server, get data from the database, and then forward it back to the client. Maybe you have a forward proxy and then you have a reverse proxy, where the reverse proxy will terminate communications going to the server and then try to understand if there's no errors and then forward it to the server. The server gets process your data from the database and forward back to the client. So that is a client-server architecture. So Docker has 2 main components, the client and the server. So we have in Docker, before moving to the client-server architecture, Docker has an engine. So this is the core software that allows you to build, run, and manage containers. So it's like a kitchen appliance, like specifically designed to work with container recipes. So the engine is designed to work with like the container recipes. So if you want to build a container, an image, and then run a container and all of that. So that's what the Docker engine does. It allows you to issue commands from the client, which is your command line, and then the client will forward this command to the server. The server will process it and then bring back your result. So we have Docker images. So these are the pre-packaged units containing everything an application needs to run. And then if you don't understand it right now, we'll get into it in just a bit. So that is the code, the libraries, the dependencies, and the configurations that your application needs to run. So in a Docker image, before you build an image, you will install all the dependencies that your application needs to run. First of all, you need Node on your machine. For you to run a Node.js application, you need Node, and you need other dependencies for the application to run. So if you want to run that in Docker, there's the same thing you do. You install Node and then install every other thing that your application needs to run in that container. So, but on our machine, what we do is we don't package our machine and then send our machine to the server. We only send our software, the executable, or basically the whole software, so that the server will build it and then execute the executable. That is the distributable software, which is the built software, the one we build. Okay, so the one we write is the source code, and then the one we build is the executable or the distributable. So Docker images they are just the source code, basically the one we share so that they can run on any software or any machine. And then we have the Docker Hub. So this is the public registry where developers can find and share Docker images. It's like a giant online library of research for all and all of that. So we can basically come here and then see Docker Hub like this. You can visit the Docker Hub. Okay, it shouldn't take much time to load. And then visiting the Docker Hub, we can see we're looking for Node. Okay, let's say Node Alpine. There's a light, okay, Alpine, the light version of Node. Then you hit enter. You hit enter. And then you come over here, you see the Node. Okay. And then where is it? Node. Okay, let's say Node. Or Node.js. Okay, it's Node.js. Okay, I'm seeing images, Node.js agents, and all of that. Blah blah. We have different images here that you can use. So you can pull any image here and then use to solve your specific problem. You have Node, hit Node. This is the official Node.js image. So Node.js is a JavaScript-based platform for server-side and networking applications. So last week, 9,510,589 people pulled this image from Docker Hub. So the total pool is 1 billion plus, and they have 10,000 plus stars on Docker Hub. Can you see how people are using Node.js? But the image is heavy. So we have more lightweight images. You can look for, okay, if you search Alpine, you see Alpine. This is the lightweight for all images. Any image that ends with Alpine, you can see if you click on this Alpine now, this is the Docker Hub, all images. People build and host images here. You can come over here and see Alpine age, Alpine 3. Blah, 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 and all of that. So you can come over this Node Alpine, the lightweight for Node and all of that, but then searching, okay, that is basically Docker Hub for you. And so there are images hosted there. You can also build your own image and then host it there. And then later we'll look at user-built images and then the images built by the Docker organization themselves. Okay, so how does Docker works? So first of all, you build images. You can use Docker to create custom images from scratch or modify existing ones. So Docker provides a specific format for describing the image creation process using a file called Dockerfile. You can basically create it without using Dockerfile, but the recommended way is Dockerfile because we have some Dockerfiles have complex configurations. So you have to use a Dockerfile to specify all the commands you want and also all the commands you want to be executed during building an image. So you basically need a Dockerfile to write all those commands. And then the second, once you build an image, then you're running containers. So once you have an image, you can use Docker to run instances of that image as containers. So each container is a running instance of the application defined in the image. So you can share images. You can share your images with others publicly on Docker Hub or private within an organization. So when you share an image with anyone, they can basically run that image and then it turns into a container. So when you run an image, it's basically a container. So benefits of Docker: faster development, and then easier deployment, scalability, resource efficiency, and all of that. So under faster development, Docker simplifies the development process by ensuring consistent environment for development, testing, and deployment. So when I build an image and I share it with you, the same way that image works on my machine is the same way it will work on your own machine. So that is the reason why containers are recommended. So it's basically when you package products in a container and then you transport those products from the US to Nigeria, those products won't be tampered with, or the goods, they won't be tampered with because they are locked in the container. And then when you bring that container here, the container will be intact. So if you decide to open it, the same thing that was in that container in the US is the same content in that container in Nigeria. So that is basically what one of the benefits of Docker: faster development. So Docker simplifies the development process by ensuring consistent environments for development, testing, and deployment. So we have also easier deployment. So Docker containers are portable and self-contained, making them easy to deploy across different environments. We also have scalability. You can easily scale your applications by adding or removing containers as needed. So that's the reason why I mentioned Kubernetes. That's where Kubernetes comes in. You can issue a command, okay, just increase these containers, make my instance run, make my application to run in 2 instances, 3 or 4 instances, depending on the traffic you're getting. So if 1 million people are visiting your application, 1 instance of a play cannot handle 1 million traffic. So you have to increase your application. You have to increase the instances. You have to make your application run in different places or different instances. So I'll make like 4 instances of your application. That is 4 types of your application running on the same server or different servers. That is what I mean by instance. 4, your application 1, a single one like this running on a server, you can make it run 4 of it. That's replicate it, the same application running 4 of it in different places. Okay, so we have also and that is where horizontal scaling and vertical scaling comes in. So horizontal scaling is, okay, that's a topic for another day. So easier deployment. So Docker contains portable and self-contained. Sorry, I mean, what I mean is containers are portable and self-contained. So making them easy to deploy across different environments. When they say portable and self-contained, everything needed to run that application is inside of the image. So when you run that image, you run the container. When you run the image, it turns into a container. So the container has everything it needs to run, packaged in that image. That's basically it. And then scalability. You can easily scale your application by adding or removing containers as needed. So when you use Kubernetes, you say, oh, scale it, scale it to 4 instances. You specify in the YAML file 4, and then Kubernetes will create another instance of the application. Okay, scale it to 6 instances, specify 6. Kubernetes will create 6 instances. Okay, bring it back to 2 because we don't have enough traffic. Kubernetes bring it back to 2. That's great. So resource efficiency, containers are lightweight and share the host operating system, so making them more resource efficient than virtual machines, as we earlier mentioned. So Docker now is one of the popular tools for developers and operations teams due to its ease of use, portability, and abilities to streamline the application development and deployment process. So as you can see, Docker is very, very important. And then uses of Docker. So Docker has these capabilities that extends across various stages of the software development lifecycle. So offering benefits to both developers and operations teams. So we have some uses here. The development and testing. We have continuous integration and delivery. We have microservices architecture, and then we have deployment and scalability. We have many of them. We have standardization and isolation, and we have version control. So let's look at all of these. The first one is development and testing. So Docker allows developers to create consistent development environments with all the necessary dependencies prepackaged in containers. So this ensures everyone on the team is working with the same environment, reducing bugs and streamlining development. Additionally, Docker makes it easy to spin up test environment quickly for automated or manual testing. That's great. Then we have continuous integrations and continuous delivery. So Docker integrates well with CI/CD pipelines. So developers can build and test the application in containers and then deploy those containers seamlessly across different environments. So these environments can be development, staging, and production. So you can go find out what development stage is. The development, we have 4 here: development, staging, and production. The development stage, the staging stage, and then the production. So this automation helps deliver application faster and more reliable. So in the development stage, that is where every developer will write their code and then push, where code review and feature review will be carried out. And if it passes, you open a pull request and then it will be merged to the staging environment. In the staging environment, it works exactly as a production environment, but that is where your application is tested. That is the, should I call, what is it called again? This kind of testing is behavior. No. Basically, this is where they test your application if it's running as expected. So it goes into production. So the team will visit the application, try to test the features if it's working as expected. If nothing breaks, after your unit testing, integration, all of that, if they test it this way and nothing breaks, it will be pushed into production. So this production is the final stage. This is where users across the globe will access your application. So once it's pushed into production, every other person using your application will be, these new features will be visible to them. So production is the final stage. So this automation helps deliver application faster and more reliable. So we have the microservices architecture I stated earlier. Docker is a perfect fit for these Microsoft architectures where applications are built as a small independent services. So each microservice can be containerized, making it easier to develop, deploy, and scale them independently. So I wish you have time to go into microservices so we can build a small microservice application, but then that won't be possible, sorry. And then we have deployment and scalability. So since Docker containers are lightweight and portable, they can be easily deployed across different environments, from on-premises servers to cloud platforms and all of that. So scaling applications becomes simpler as you can add or remove containers based on demand. Based on demand means if you have higher traffic, add more containers, have lower traffic, remove the containers and all of that. The standardization and isolation. So Docker ensures consistent application behavior across environments by packaging all dependencies within containers. So this reduces compatibility issues and ensures applications run as expected, regardless of the underlying infrastructure, as I earlier mentioned. Okay, and then last but not the least, we have version control. So Docker images can be versioned, like allowing you to track changes and then roll back the previous versions if needed, or if you encounter any bug. So this provides better control over your deployment and simplifies troubleshooting. So now that we've understood what Docker is, the benefits of Docker and the uses of Docker, I guess we should just proceed. So moving on, it's becoming more interesting. We have the Docker components. So first of all, we have Docker client and server, which is the first component, because without this, you cannot be able to build images and containers and all of that. So the Docker client, which is known as the Docker, it is a command line interface you use to interact with Docker. So we can think of this as the chef in your container kitchen. So the chef uses recipes to instruct the kitchen appliance to prepare dishes based on your instructions, all of that. So the Docker client allows you to build images from the Docker files, run containers from images, manage containers. That is, managing containers means starting, stopping, restarting, and removing containers, and all of that. So you can also manage images. You can list images, you can search images, you can pull images from Docker Hub, you can push your own images to Docker Hub. So you can also interact with Docker registries like the Docker Hub. So we have private and public registries. As we proceed, we will learn more about this. So we have the Docker client. This, what we just discussed now, is the Docker client. Now the Docker server, also known as the Docker, like DOCKERD, Docker. So, and it's also known as Docker daemon, DAEMON, Docker daemon. So daemon, this is a daemon process that runs in the background on your host machine. So it's the actual kitchen appliance that carries out the instructions from the chef. Like, that is the Docker client. So the chef forwards those instructions to your kitchen appliance, and then it prepares the dish or all of that, and then returns the result. That is what they prepared to you, so you can eat and then feel all right. So the Docker daemon is responsible for building Docker images based on your specifications in the Docker files. So running containers from images, managing the life cycles of containers, that is starting, stopping, and restarting. So we also have managing the underlying resources, like the CPU, the memory, storage, and then all of that allocated to the containers. Okay, so this is basically Docker client and Docker server, which is also known as the Docker daemon. So the client issues commands the server processes those requests or commands, and then returns the results to the client, where the client will display the result to the user or execute those commands as expected. So the Docker client and server can run on the same machine, or you can configure the client to connect to a remote Docker server, but that is it's out of the scope of this class. We're not going to be trying to configure the client to connect to the remote Docker server. And then the clients communicate with the server using a REST API. Basically, it's they use GraphQL, REST API. And then Docker also provides an SDK that allows programmatic interaction with the Docker daemon. So this is just the introduction to Docker client and server. All you should know is the Docker client is the command line used to issue commands, and then the Docker server is running in the background. So setting this all up by yourself is a kind of a cumbersome. So that is the reason why we have the Docker desktop. So once you have the Docker desktop installed, you don't have to worry about setting up clients or server and all of that. Everything is prepackaged in the Docker desktop. So you install it, and then if you don't want to use the command line, the user interface is for you to click buttons and then do every other thing to run things. So following up, we have the Docker images. So Docker images are the core building blocks of containerized applications in Docker. So basically, they are self-contained software packages that include everything needed to run an application. So what does this mean? It means the application code, the runtime environment, and the configurations. So the actual code that makes your application function, the libraries and dependencies. So the application code is the actual code that makes your application to function. And then the runtime environment, that is the libraries and dependencies required by the application to run properly. So basically, this could include things like the Python libraries, the Java runtime environment, or the NodeJs for JavaScript applications. And then we have also the configurations. So any configuration files or settings needed for the application to function as expected can also be packaged in an image. Okay. So basically, what you can think of Docker images. Like a recipe booklet, that is the image containing all the ingredients, that is the code, libraries, and instructions needed to prepare a specific dish. So when you open that recipe book, and then you start creating your dish, and once your dish is created, it becomes a container that you can run, you can eat your dish. Oh, that's sweet. So we have the key characteristics of Docker images, the key characteristics of Docker images. We have self-contained, it is layered, and it is versioned. So images bundle everything needed to run the application, making them portable and independent of the underlying environment. So they're also layered. Images are built in layers, where each layer represents a step in the build process. So this allows for efficient storage and updates. As only change, it only change layers needed to be rebuilt. So they are also versioned. So images can be tagged with versions, allowing you to track changes and then roll back to previous versions if necessary. Okay, so that is basically what images are. So how are images used? You may be confused. So you can use Docker images to create, you can use Docker to create custom images from scratch or modify existing ones. So this is done using a special file called the Docker file, which specifies the instructions for building the image layer by layer. So we have running containers as well. So once you have an image, you can use Docker to run instances of that image as containers, as I earlier mentioned. So each container is a running instance of the application defined in the image. So you can share images. So Docker allows you to share your images with others publicly on Docker Hub or privately within your organization. So we have benefits of using Docker images as well. We have consistent environments, we have portability, faster deployment, and version control. So we're not going to be going over that. So the next component of Docker is the registries. We've talked about the registries once or twice. So what does the registries do? So registries act as storage facilities for Docker images. So they are essentially online repositories. You know what a repository is? Like a repository on GitHub. So where you create a repository and then store your code. So you can share that repository with someone else so they can pull and then run your software. So they're essentially online repositories where you can find, share, and manage Docker images. So there are two main types of repositories, registries. So we have one, public registries, and then two, private registries. So we have the public registry is the Docker Hub. That is the public registry provided by the Docker community by themselves. And then you have private registries. You can decide to create your own project. Docker also provides an API to create a private registry that you can use with your organization, only within your organization, to create images, build containers, and all of that. And when we start using Fly.io, we get to understand all of this. So just get to wrap your head around all of these things. When we start posting applications on Fly, you see how Fly makes use of Docker. So moving on, we also have containers. So containers are the running instances of Docker images. So imagine a Docker image as a blueprint or a recipe, as I earlier said. So containing the libraries and configurations for an application. So a container, on the other hand, is the actual prepared dish based on that recipe. That is a running instance of the application defined in the image. So you say you want to build an application that logs hello world. So you build an image, and then once you run that image, and then it turns into a container that outputs your hello world. So containers are also isolated. Containers run in a sandbox environment, isolated from each other and then the host machine. So this ensures that the applications running in containers don't interfere with each other on the underlying system. They're also lightweight. Unlike VMs, virtual machines, containers share the operating system kernel of the host machine. As I earlier said, they are also portable and they are ephemeral. Ephemeral here means containers are typically designed to be short-lived and disposable. So once a container finishes its task, it can be stopped and removed. Because when you have a software installed on your machine and then you run an instance of that software, when you close that software, that instance is destroyed. But when you open that software again, it creates an instance with your data from the database and the states of the application when that instance was closed. So containers are also ephemeral, where when you run a container and then you destroy that container, it is gone. But then when you run that, there's an image, you already have an image that you can run containers from. So when you run that image, another instance is created, which is a container, and then the data, the image already have everything needed to run that software. So your software is up and running again. So that is basically, okay. So how are containers created and used? So when you build an image, you use Docker to build custom images or use pre-built ones from registries like Docker Hub. And then you run your containers. So once you have an image, you can use Docker commands to run containers from that image. So each container is a separate instance of the application defined in the image. I keep repeating this. Each container is a separate instance of the application defined in the image. So let's say I am running Discord here. So I can decide to open another instance. I can decide to click here and then say, okay, there are options. Okay, show not like this. Okay, this. Okay, I can decide to open a new window from this browser, and that is another instance of this software. So that is basically how the containers work. When you create a container from an image, it's an instance of the application. We create another container, that is the second instance of the application. So once you build images, you can host them on Docker Hub, and then you can pull them to run containers. So managing containers. So Docker allows you to manage the life cycle of containers. You can start, stop, restart, and remove containers as needed. And Kubernetes helps us with that in orchestrating containers. Where you see, okay, we specify the minimum amount of containers needed to be run. So what Kubernetes does is, once a container dies, if you want to run 6 instances and something occurs and your container dies, Kubernetes will automatically create another container from the image, from the specified image. So that in that case, that image is on Docker Hub. So Kubernetes will automatically pull it from Docker Hub or your private registry and then create another container from that image, because everything you need is in that image. Okay. So if you you can specify the minimum amount of applications to be running. So if something happens and 3 instances of your application dies, if you have 6 instances running and 3 instances die and another one try to also go down and leaving 2 instances, Kubernetes will say no. The minimum amount of containers specified is 3. So there must be 3 containers up and running. So you must not go down. Kubernetes will quickly create another container to replace the one that is down. If the problem persists, it will continue creating and that basically, if there's any problem that will occur in that way, it should be at the time you want to host your app. So you notice and then correct your mistake or your error, fix the bug. Also have benefits of using containers: faster development and deployment, resource efficiency, scalability, and isolation. So that is basically the Docker components, the Docker client and server, Docker images, registries, and containers. So this may sound weird, but as we move on, we try to practicalize things. And our time here, we have just an hour left. So let's see what we've got. So the Docker basics, we can ensure if a container is running. Okay, so this is time we go to I already have my Docker desktop up and running, and it is clean. It's clean. There are no images, there are no containers, there are no volumes, there are no builds. Okay, basically what I would do here, I can just go back to my command line interface and then clear it. And then I have, okay, so let me should I just maximize? I think this is better, like this. Okay, great. So you can run Docker PS, and then there are no containers. We don't have any running containers. If we have any running containers, we have the container ID, we have the image, we have the command, the created status, we have the ports and the names. So now I have my Docker desktop running. That is the reason why, as you can call, if you have engine running, the Docker engine, which is the Docker daemon, is running. So that is the reason why I'm able to use the Docker client to communicate with the Docker daemon. And once I do Docker PS, the Docker daemon will search for running containers and then bring back the result. There's nothing here. Okay, that's basically it. So now we know that the daemon is running. Without even doing that, you can come over here and then see that, okay, engine is running, and you can pause it and then resume, basically. Or you can even quit Docker desktop. Okay, so if you, I told you to install Docker Desktop earlier. No. I told you to install Docker Desktop earlier, and I believe you've done so. Okay, so now you can see Docker info as well. And then Docker info will bring back the info about your Docker. The version is version 25.03. Our context is Docker Desktop Linux. Debug mode is false. Plugins, we have Docker BuildX. So this Docker BuildX is basically what the software used to build images. And then we have Docker Compose. So this Docker Compose is also used to orchestrate containers like Kubernetes, but Kubernetes is more powerful. We're not going to go into Docker Compose. We have Docker Dev environment. We have this Docker Dev environment, which manages Docker extensions. Then we have, which one again? Extension, I think that's all. We have a server. This is basically the client. And then we have the server here. We have containers 0, running 0, pause 0, stopped 0, have images 0. And then we have the server version to be 25.03. Then we have the storage driver overlay to, and the backing file system is EXTFS. And then we have the support D type true and all of that. So you can say Docker info, and then you get to see. So warning, daemon is not using the default second profile. And why that is showing is if I come over here and I go to, I discarded that earlier, but there's something in my machine tampering with my configurations. Okay, so Docker info, and then you see the information about your client and then your server as well. So this is the basic command for Docker. You just see, it's just like npm. If you want to install, you say npm do this, npm do that, npm run this, npm do that. So when working with Docker, you first of all use Docker first. So the Docker info, the status about the server and all of that. You don't need to go into explaining Docker this and Docker that. So how do you run a container on the command line? Okay, so we can run a container. So what basically happens if you run a container on a command line and you don't have that container on your local machine? So if you don't have that container on your local machine, okay, what the Docker daemon will do, it will search for that container, that image on your local machine. And if it doesn't find the image, it will head over to Docker Hub. It will search for that image on Docker Hub, and then it will pull it to your local machine, and then it will run the container. It will run an instance of that image on your machine, which is a container. Okay, so you can run a container and then make it interactive. So if you want to run a container, basically what you will do is you issue the command Docker. Yes, I should zoom in. Okay, this is oops. Okay, zoom in again. This is okay. This is good enough. Okay, so now you can see Docker run, and when you say Docker run, you can basically, there are other options to this as well. So let's say we want to run the Ubuntu, image, want to run the container from the Ubuntu image. So what you will do is you can say Docker run, and then you can see, you can make it interactive. So when you say -i-t, and then you say Ubuntu, then you specify the tag. So we have Ubuntu, we may have version 1, version 2, version 3, version 4, version 5, we don't know. But what we need to know is the latest version is the stable version. So maybe they changed the versions, and then we don't know what may have happened. But all we know that the latest version is the stable version. So we say latest. So we want to run the Ubuntu latest. Okay, but we don't have it locally on our machine. So, and then we'll see if you specify bash, this is a different case. Okay, but if you don't specify bash, you can see Docker run Ubuntu latest. And then if you hit enter, look at what, unable to find image Ubuntu latest locally. And then let's see what happens next. The latest pulling from library Ubuntu. And then it is pulling from Docker Hub. It is pulling this image from Docker Hub. And this is the size of the downloading. The size is 29.71 MB. That is the size of the image from Docker Hub. So now downloaded newer image from Ubuntu latest. Okay, so you should say Docker images. And then we have repository is Ubuntu. This is, and it is a repository on the Docker Hub named Ubuntu that hosts all the Ubuntu images. So the tag here is latest and the image ID here is 354 blah blah blah. And then it was created 4 weeks ago and the size is 78.1 MB. So we now have this Docker run Ubuntu latest. And then if you open your Docker desktop as well, if you don't like interacting with Docker demo with the command line, you can open your Docker desktop and now we have a container. So this container name is Clever Goldstein. And then if the status here is exited, and then the last started 39 seconds ago, and all of that. So the image here is Ubuntu latest. So we did not run it interactively. So once we run it, it did its job and then exited. So if you come to images, you have Ubuntu, and the image ID is this. And then the status here is in use, created 28 days ago. The size is 78.05 MB. The action, so you can run once you click run, option settings, run a new container, you run it. There are no logs, you can inspect. And when you come here, you see the created part being bash, and then all of that, blah, 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 blah. Okay, now if you come to images, you see this one image. If you come to containers, now you have 2 containers. The first one was run 2 minutes ago, and the second one 17 seconds ago. This image is creating all these containers. This is the first instance of that image, that the running instance, which is a container, and this is the second running instance, which is also a container. Then you can come over here and then delete it. Or let's grab this ID and then come over to our command line and then see Docker rm, and then we specify the ID. We hit enter. And then if you come over to our Docker, rm means remove. And if you come over to our Docker desktop, there are no more containers. The other one, we deleted it manually. And the second one, we used the command line to delete the container. So this is basically awesome. So moving on, we've created, we've pulled the image from Docker Hub and then run it as a container on our local machine. And we can make this interactive. So let's make it interactive. So now there are commands I will add to this and I will try to explain. So the Docker run -I, make it interactive. That's leaving the std in open. If you leave the std open, that is the standard input open, we can pass in commands to this container and they'll be executed in the running container. Oh, this sounds weird. Okay, so now you are saying leave it open and then enable the teletypewriter. You can leave it like this, -T. Enable the teletypewriter. So when you say leave the std in interactive and then enable the teletypewriter here means leave the stdt open and then enable the teletypewriter so that anything I type will pass to the std in and then it will be passed to this bash of the container. So we say Ubuntu latest and then the bash. We want to pass this command to the command line in the Ubuntu latest container. So we say the bash. So if you hit enter now, look at what happens. Okay, so now we have the root. And then if you say ls, and then you have all the files in this. And then you can even create directories, mkdir, just testing. Then you hit enter, and then you say ls. And then now you have just testing as a directory. Now you can cd into just testing. And mind you, this is a running container. This container is running, but I'm executing commands inside of the container. Can you see how awesome that is? So I never had time to basically discuss the Docker architecture, the whole of the architecture, and how it is run on top of another software, but it's due to time, and we don't have time for that. So you can cd to your previous command like this, and then we're back to where we were. That is the root. And then you can see is it rm directory. Okay, remove directories, make directory arrange. Oh, just testing. Is it? Okay, I mean, it's not like that. mkdir rmdir. Okay, just testing. A simple command I've forgotten. Okay, so now I've deleted the directory, and then if you say ls, and then you don't have the just testing directory anymore. So mkdir is make directory, and then rmdir is remove directory. Then you can clear your terminal as well. A control sequence attempted to clear scrollback history. Allow this in the future. Okay, allow. So if you say ls, and now we have the home, the live, the and all of that. So now we are now interacting with this. So inside of this container, what we can do is we can create an application inside of this container. You can see we can create mkdir app. So when we create app, we can cd into app, and inside of this app we can see touch package JSON. Okay, it's touch, no toku. Toku. Touch package JSON. Say ls, and then we have a package JSON. And then we see we don't have node installed in here, so there's nothing we can do. And then you can see Vim. I don't know if Vim is pre-installed. Vim package JSON. Okay, Vim is not pre-installed, or you can say vi package. I know most of us don't know what Vim is. It's default text editor. Okay, vi is not pre-installed. So we can say, okay, now we want to remove package JSON, and then we want to go out of the app. Want to go up out of the app, and then say ls, and then we still have our app, and say rmdir app. Then we say ls, and then we don't have the app directory as well. Then we can say clear, and then we've cleared our. So we can say exit, and then we exit out of the container. So what if you want to run a container with a name? Then we can say docker run dash name. Then we can see Ubuntu yo. I say Ubuntu yo. And then we hit, okay, and then we say the name of the image is Ubuntu latest. Hit enter. So now we're not running it interactively. So if you come to our here, we have the Ubuntu yo container that we just ran, and now we have a container name. We don't have, now we can even delete a container using its name. So we can come over here and say docker remove Ubuntu yo. And now Ubuntu yo, it's Ubuntu or Ubuntu. Oh, I'm saying Ubuntu. What is it? Oh, it's like the container name was Ubuntu. Okay, let me just check the history and see. Ubuntu. Wow. So I said Ubuntu you, I never noticed. And then while deleting, I still specified Ubuntu you and it deleted. Okay, so that's great. So we can delete a container with its name and then all of that. So we don't have to worry. So that is how to run a container interactively and all of that. So while running, you can cd into the container and then execute command, and then you are good to go. Before I forget, while the class is ongoing, if you have any questions, you can raise your hand, and then or you can type it in the chat, and I will answer you ASAP. So we have run the container. We've also named the container. Okay. So you can also build an image. We'll learn how to build images later on, but if you want to build an image with a tag and all of that, you can specify the tags. But now it's just running images. And then if you want to pull an image, let's assume we don't have, okay, let's try to pull Ubuntu. You see, if you want to pull an image from Docker registry without running it, you can say Docker pull. Then you see Ubuntu letters. And then let's see what Docker will tell us. It's Ubuntu again, not Ubuntu, Ubuntu letters. And hit enter. Let's see what the client will tell us. Okay, now it has sent this request to the server. So letters pulling this, and the image is up to date for Ubuntu letters. So we already have this image. So what next? View a summary of image vulnerabilities and all of that. So if you come over here, you can say Docker rn Ubuntu letters. There are referred from them, no such container of, okay, this is an image and not a container. Okay, we have our own image here. Then you can delete this image. Delete it. Image. Okay, we have a container running with the image. So we'll come over here, delete the container first, come over to this image, and then delete the image. So now we no longer have the Ubuntu letters. So if you say Docker pull Ubuntu letters, then let's see what you've got. So now it will pull this image from the Docker registry. That is Docker Hub, the public registry, pulling FS layer and then downloading the image. Okay, so that is how to pull an image from the Docker, from Docker Hub or Docker registry. Okay, you can come over here to Docker Hub. Okay, let's not go into that. So this image is being pulled, and then after pulling the image, okay, so now we have this image. Let's see Docker, okay, so Docker, Docker images, okay, Docker images, and then we have Ubuntu letters created 4 weeks ago, and then we just pulled it. Okay, so that's great. And now, what's next? The next thing we want to do is to start and stop a container. How do we start and stop containers? We can grab a container ID. Let's come over here and then let's create, you can see Docker run. Let's see, let's just complete this name Ubuntu. Okay, should we limit? Let me just change it to Ubuntu. So Ubuntu, okay, let's say Ubuntu KC. And let me see. The image we want to run this container from is Ubuntu latest. So notice the order of this command: Docker run, and then you want to tag a name. You want to add a name. You don't want it to be a random name like Blue Silver, Master Running, or all of that. You want to tag it a name, and then you want to run this image from this this container from this image, Ubuntu latest, and then you hit enter. So the container is run, but then we're not running interactively, and it's not doing anything special. So when you come over here, you see that you have an image, and you open your containers, you have this thing here. So right now, this container, we ran it, but then it stopped. So we want to start it again. So what you will do is you just copy the ID here, and then you see. Okay, first of all, let's look at the time. Last started 22 seconds ago. So let's come over here and do this again. Docker starts, and then we paste in the ID, and then we hit enter. So if you come over here again, you see last started 0 seconds ago. Okay, now we'll start it with the name. Let's allow it some seconds. Okay, 8 seconds ago. So let's come over here again and then see Docker start. We see Ubuntu AC. Then hit enter. Now this time around, if you come over here and check, you see that last started 0 seconds ago. So you can start a container by its ID or the name. Now if you click on this container, you can see that it has no logs. And then if you inspect it, you have all the information about the container. You can check the image. The image is here is Ubuntu based on Linux. I can see the name is Ubuntu KC, which is the container and all of that. We have the mount, we have the runtime, we have the platform, and every other thing, labels. We have organization, open containers, image, ref name is Ubuntu, and the latest version which we are running is 24.04. And then we have the build mount and all of that. So you can come over here, you can start it again. The log can start it again, and then once you start it, it stops. You can refresh it and all. You can restart, start, and stop because it's doing nothing special. So you can just come over here, you go back, and then you have your container. It started 6 seconds ago because we started it there. Okay, so that is how to start a stopped container. So container logs, you can also see, come over here and see Docker logs. Docker command. It's only one argument. Okay, you can say Docker logs, and then we'll specify the container name. You can say Ubuntu KC. And then there's nothing because the container is not actually running. So we want to, okay, basically we have to create a container that we can print the logs. Okay. So let's create a Docker container that will print out logs. Okay, so how we have to create an application. Okay, so when we start, let's leave that for now. When we create a basic node application with Docker, we can print logs. I can come back to this. So you can also delete. We've learned how to delete a container. You can say Docker rm, the container ID or the container name, and then you can say Docker rm your stopped container or anyhow you want to do it. Okay, you can say Docker rmf. Okay, let's, for example, if you want to stop a running container, you can also say Docker rm and then the Ubuntu latest. If it's running, it will not stop. Okay, say Ubuntu KC. It will not. So you have to add another. You have to force it to stop if the container is running. So if the container is running, you have to add -f. You want to forcefully stop it, and then the container will stop. That is how to stop a running container. Okay. So moving on, we basically learned the Docker basics, how to ensure our Docker is running, how to run a container, how to name a container, how to start a stop container. There's more to this, but I just want to brush on the surface so that you get to understand the basics. Because if you want to talk about Docker, we have to take a couple of months to go in depth. Okay, so now we have Docker images. So we've already discussed what Docker images are, and then we can also list images by giving the command Docker images. So we've learned how to list images by saying, okay, Docker images, and then we have this Ubuntu latest. Okay, then you can say Docker run node Alpine. This is the light version of node. We have the normal node, which is about a couple of 100 MB or 100 gig, but this is the light version of node. And if you hit unable to find image node Alpine locally, then it will pull from Docker Hub. So pulling from library/node. And so now it's, as you can see here, we have 3.6 downloading 4.7.3 MB download complete. Okay, so when it's done downloading, so still downloading here, it's showing downloads complete. It's extracting some things and then downloading the necessary libraries bounded in the image. So after it's done downloading, blah blah blah, a couple of minutes, and boom, I think it should be done. Okay, extracting. So it's done downloading, so extracting, downloading. Okay, now if you see Docker images, and then you have node Alpine. The tag is Alpine, and then they create the latest version is 3 days ago, and the size is 151 MB. Then we have Ubuntu, the tag is latest, and then 35880. And then we have Nodes, books, and Sleep. I have other ones as well. And let me check here. I want to see the name. What is the Docker file? Okay, Docker file here. Okay, I will have Bookworm Slim, Node 20 Bookworm Slim as well. You can also use that to pull that from the Docker, this and all of that. So now we've seen how we can run the Docker images and list the images being pulled. I will see how we can pull images from Docker Hub. So how can we build images with Dockerfile? Okay, so most of us have been waiting for this. So we can also list images, including the non-running ones. We can list images as only the running images. Then we can say we want to list images in Docker images, and then we can say false. Then we can say the name is equal to, let's say, the ones that start with node. One of these images that start with nodes, not matches found, node. Okay. Oh, so let's see. Okay, node. Invalid filter. Okay, no. Okay, so node. No matches found. Okay, we're not getting. Okay, we can see that, so you can filter images, you can list images. Maybe you have Node Alpine, the book slim, the list slim bookworm, and the rest. So you want to filter only the images with that start with Node. Okay, that's basically, I don't know why it's not doing it. We don't have to waste our time on that. So we can see Docker images dash quiet. It's quiet, not quit. Whatever means they're just quiet. And then this time around, it lists only the IDs. So we just want to get the IDs. Nothing more than that. So we can even pull the quiet only lists Docker images, the IDs of the images are nothing more than that. So we can pull images. We can even pull, let's say we want to pull Docker, pull Ubuntu, but then you say version 18 or 18.4.3. You want to pull a specific version, not the latest, and this will pull this for you. And then these are two different images. This is different from the latest. We pull this for you, and if you run the software with this, it's different from the software you run. The container, if you run a container with this, it's different from the container you are running with the latest version. Then you can even go ahead and pull Nginx. I love Nginx. Most of us don't know what Nginx is, but it is a web server. It serves as a web server, a reverse proxy, a load balancer, and more. I love Nginx. Okay, we're not talking about Nginx. Let's move on. We have we can also build images with Docker. Okay, so now I think we are done with our command line. We still come back, but then let's move over to this one over here. Okay, I'm sorry. So, okay, so first of all, let's do something more important. We'll do something here. We'll come over here. Okay. I guess we should open. Let me just open that. Okay. So what's making it take time? Okay, so we have casing notes, the 8 here. I didn't push this to GitHub. I thought you wouldn't need it. Okay, so let me just zoom in a bit and then create a new folder of 9 Docker in here. Okay, I created in the Prisma. Okay, this is not where I want to create it. I just delete it. Okay. Change directory. Let's say nkdir 9 Docker. that. And then we have a 9 Docker file. And inside of this, let's clear our terminal. Then you can see touch with cd9 Docker. Then you see touch Docker file inside of the hub. Inside of this Docker file, you can write commands that the Docker server that we pass to the Docker server for it to execute. So basically, let's say we have an application inside of here. Let's say we have an touch package JSON. Let me say npm int-y. Okay, basically we have a package JSON, so we don't need to do that. But if we open the package JSON now, okay, we can just remove it and then do that. Do npm int-y. Need to create a package JSON for us with all we need. Okay, so now we can go ahead. Inside of this place, we have scripts. Can remove this. You can see the start script. The start script is node index.js. Now we come over and say touch index.js. Then we have our index.js file. And inside of here, we see y true. Y true log hello Docker, like this. Y true log hello Docker. And then we can say okay, basically let's just leave it like this. Or we can see we can write a function. So main. And then we see return sets interval, and the interval will take function and say 1 second. Then we see log okay. Then come right here, see main. Or you can make this an yeah, immediate input. Okay, you can do this like this. Like this. So if you come over here and then say node index.js, have hello Docker after 1 second. After 1 second. Okay, then we can stop this and then go over. So this is our application. Basically, this is our application. So we want to build an image with this so we can run this application in containers. So now we have our Docker file. So what do we need when we want to build this image? When we want to run this on our machine, the first thing we needed was Node, because without Node, you cannot run Node and then index.js. So first thing we need in our Docker file is the Node, and then we use the light version, which is the Node Alpine or the Bookworm Slim and all of that. So let's use the light version. So what I'm trying to show you here is to build with Dockerfile. Don't mind the commands. The next is the commands, and you can see by yourself. The next is the commands. Okay, we don't have time on our side, but I will touch the basic ones. We start from top to bottom, and then you don't have to worry. So let's get into this fast. Don't worry about the commands. While I'm typing, I will be explaining, but then we'll still touch the commands. So for the first thing we need is from. From here is specifying the base image. So the name of the base image to use, because there are base images already built. So we say the base image to use is Node Alpine. We don't know the version. You can say Node Alpine 20. like this. And then we can see as, and then the as here, the name of this build stage, but this is not the build stage. Okay, now we've specified the base image. So what else do we need? Then the work directory. So the work directory here is what it simply means. After it pulls the base image, then the work directory, what it will do is it will create the folder app, and then CD, it will change directory into the CD. So everything that will be happening after this work directory will be happening in our app. Let's say the work directory is in the app. So this command here, which will make node will say make directory app and CD into app. This is what this command is doing. Make directory app and CD into app. So when you CD into app, there was subsequent command to be executed in the app. So what is our subsequent command? Is copy. We copy our package. We don't even have any package. We have our package JSON. Okay, the start command is there. So we copy our package JSON into the app directory. We copy it into our container, which is the app directory. And then we say, if we have anything to install, this is where to run npm run npm install. And then we see, you can say dash omit equal to dev. So if you are building for production, if you specify this, it will install only the production dependencies to make our image more slim and more lighter. But we don't have anything to install. But this is a basic image, and then you can say expose. Okay, let's say 3000. Expose 3000 here basically means you are exposing this port that can be used to connect externally to this container. You are not saying, as this is exposed, you cannot connect to this port. The only thing you can do is you can then tag another port, you can forward this port to 8080 on the host machine. This is the host machine. So if you want to access this app, you can say docker run -p, say docker run the app name -p, and then we'll get to that. And then so we'll expose 3000, and then down here is CMD here. This is the executable, and then it's npm start. So this is the command that will be executed when our container starts running. Immediately our container starts, this is the command that will be executed. Okay, so now that we've written this image, we can basically say docker build. And then where is our package, our Docker file is here. So we want to use this Docker file in our current directory here. So if you have a Docker file in another, let's say we have a directory of order, and inside is a Docker file, then you see order / Docker file like this. Or you don't need to specify the Docker file. Since the Docker file is located inside, you just say order / and then the Docker file is /order like this. So the Docker file is inside this directory, so to use the Docker file to build. But since our own is in the present directory, you just hit enter, Docker build, and then let's see what happens. Okay, so what is taking time? Docker build, use the Docker file in our current directory. Okay, building like this, and then we'll look at the logs. Now let's go up, and then we have building 1.5 seconds, 8/8 finish, load build definition from Docker file. And then the Docker file, 116 bytes, load metadata from Docker Alpine. We already have Docker Alpine you can also specify Docker ignore. So the Docker ignore file, every other thing is what you want Docker not to include in the image. Let's say we don't have node modules, but we can say the node modules. Docker shouldn't build the node modules. It shouldn't include it in the image. Have the load build context. And then the second part here is it will install this node Alpine, and then it will create this working directory, and then it will copy our package JSON, and then all of that. So now we have an image, but this last one here won't be executed. So when we run our container now, it will be executed. So if you come over here, then you can see here that you have optimistic Williamson. So this is it uses the node Alpine image. And then if you run this, it starts, the status here is loading, and then it is now running. Okay. What happened? It exited. Williamson. Inspect. Okay. Okay, so why is it now? Okay, we can detach it. We can detach it and then run it. You can see docker run -d. Let's grab the ID here and then make it run in the background. Docker run -d. Then we don't have the name. You can basically paste the ID. Okay, this one, no such image. Okay, it's not the container, but the image. Where is the images? Node, node Alpine. Okay, what exactly was I doing? Was I running or building? Because we have images here, node Ubuntu, then we have containers. Okay. Docker build. Okay, it's a random. Images. 2 images. Okay. Okay, so where is it? Oops, oops, oops. Okay, so let's tag it. Let's just give it a name. What you have is Docker build. Okay, build Docker build -t. Let's say the name is basic node. Okay. -t and oops. So what's happening? Unknown. Okay. So the dots here. Oh, shit. What is happening? Okay, so basically we have, it's saying the -t here is not. Wow. All these options here, I'm trying to see if is it -t or -c? It's supposed to be -t. That is the image tag. Or it's saying oops. Docker build as t, okay, node app, and then in our present directory. So getting this, I think volume out. We have the build. Okay. First of all, we need to the image is built, but then view details Docker build belongs. Okay, let's see how we can. It's okay in the build. Okay. Basically, I was looking for it in the images and in the container. Note now it is in the build. Okay, so we have the name here. The name of the app is 9Docker. The builder is default, and then created just now, completed, and then we have we don't have any. If you click on this, okay, so we have file operations and all of that, node Alpine, the open telemetry traces and all of that. So we have everything here. So the Docker file is located on https GitHub with of accessible KodeCamp 4 gits, and then this ID, use timing. We have the source. And if you click here, this is the source of our Docker file npm start. We also have the logs. Then the logs here, we have also the history. And then this is the ID. Okay, so while this is still giving us, okay. It's not going. What's happening here? These are builds. This is basically builds. You know the image. The image is supposed to be here. Okay, so let's see Docker images. Okay, so the repository is none, and then the image ID is this. Okay, so now let's come over here. 8 minutes ago, let's see Docker run. Okay, so now it's throwing an error, cannot find app index.js, module resolution, and all of that. Okay. So now, because there's no tag, and then this Docker desktop fails to show us, okay, and now it appears. Since the image is dangling, so if you try to run it, run the image, and if you come to containers here, we have 11 seconds ago, vigorous whatsoever, it is running, and then if you open it in the logs, you see that, okay, Docker npm start node index.js, error cannot find module app index.js. Okay, Israel dangling means it's not stable because there are errors with it, and then maybe something is wrong. Okay, so after we copied everything and then we exposed this, we forgot something. We forget that we have an index there. So we add everything. We add everything. This simply means copy every other thing in our local machine, in our machine. This is in this Docker file directory, and then move it to the app directory. So copy every other thing here. So we also review this Docker build. Basic node. This is the tag as T. And if this tag doesn't work now, something is wrong. Okay, I'm not gonna use the tag. We just build it. Docker build. Our current build, not build. Docker build. Yes. Great. So the tag is working. Okay, I was doing a mistake here. Not client. Where's the client? Well, I've tagged the name of client. Okay, let's see. Basic node. Okay, so now we build this app. Now, if you come over to this place, come over here in the images. In the images, we have great. So the reason why it is like this is because I have an account with Docker Hub. So my account username is Christopher Sesu. So every other thing that has to come with this, the username first slash, the tag has to come, and then you can say, okay, now let's see, I can review this or not here. I can basically review this and then see the version is version 1.0.0, and then here, if I hit enter, and now if you open the Docker desktop app, you see that, okay, I've built this app, and then the tag here is 1.0.0. This is not latest. This is the tag is basically the version. And then if I run this, I run it, and this time around, we shouldn't have errors. So if it's running a new container. So now this is the container, and then we should have some logs. Okay, this is the logs. First of all, in the logs, it executed the start script, and then the node index.js, and then what we wrote in our index.js. You can see the stats as well, getting container statistics. You can see the files inside of our application, refreshing container files. So inside of our container, we have the user, the var, and then the app. Wait, okay, look at the app. And if you extend this app, inside of the app, we have the Docker ignore, the Docker file, index.js, and the package.json. So this is basically where our application is located. So this is a complete file system. We have the mount, we have the media, the proc, the root, and all of that. So if you come over here, you can still see that the logs are, we have hello Docker 42, 43, and it will not stop. So you come over here, we stop it, or we copy the ID, and then we come over here, we say Docker, and then we paste the ID. And if you come over to the containers, if you open our Docker desktop, come over to the container, then you see part of command fade, signal, sig10, sh node index.js, complete log bound. So it's no longer running. So you come over here. So we have a whole lot of containers over here. You can delete this one, delete forever. Okay, fade. These are images, not containers, please. You can come over here. We have run. Okay, now you can run a container with a name. So we actually built our container, we gave it a name, and then we can see Docker run the dash name basic node, and then we can specify that we are running it from our, okay, which image is that? We're running it from this image, running it from Christopher Sesu basic node. You can just come right and see Christopher Sesu / basic node. and then you hit enter. So we specify the run, we specify the name. We want to attach this name to the, okay, as you can see, it is running directly here. Basic node, Christopher Sesu basic node. So this is a container. We've grabbed this image, a container, and then we can see the logs right here. And then we can come over here and you can see Docker logs, and then you can see basic node, because that is the container that is running. And then we can come over, we can see the logs. Can you see the logs? All the logs. We run it again, you can see the logs all over. The logs are being seen. The first one, it executed the command and okay, it's now logging and logging and logging. So we can come over here, and then you can see Docker stop Christopher Sesu slash. Oh, Docker stop, no, not the image, is the container, basic node. Okay, basic node has stopped. If you come over here, I can see it has stopped. Okay, that is basically it. Okay, so now I am logged in. I am logged in. Am I logged in? Yes, I am logged in. So as you can see, I can simply sign out. When I sign out, let me sign out so you can see what's going on. Okay. Hub, Docker desktop, Hub, Docker.com logout clients, and all of that. So I don't know what's trying to show me, but it's showing me something. It's trying to log me out. And if you come over here, okay, now I am signed out, and then I can sign in. So if I don't sign in and I try to push my image, I say Docker push Christopher Sesu slash basic node. And if I hit enter, the repository, okay, I am not signed in. Okay, request denied. Request access to the resource is denied because I am not signed in. So if you want to sign in on the command line, you can basically come here and say Docker. Is it Docker log in? It will ask for your username. But I'm using Google to sign in, and I don't have the. As you can see ID. You can with your Docker ID or email address to push and all of that, blah blah blah. You can log in with your password or personal access token. So I don't have the personal access token here, and I don't want to generate it. Using a limited scope path grants better security in required. Head over to these access tokens. So if I enter my username, okay, let me just click this first. Come back to the command line here, and then enter my username Christopher Sesu. I'll hit enter, and it will request for my password. But since if I want to sign in, I'm using my GitHub. Okay, let's for instance say I'll try to sign in here, and if I click sign in, look at what will happen. Okay, so I will be prompted to sign in, but if once I click continue with Google, I'll be automatically signed in, and then I'll come here and say create your sign into Docker Hub. Okay, I don't have the access token, so I can't sign in like that. If I put in a wrong password, okay, let's say I put in gibberish, then I hit enter, and then it will process my password for a while, and it's an error response from daemon, this and that, unauthorized, incorrect username my password. But if I come over here and then I hit, I just click on continue with Google, it will automatically log me in. And once I'm logged in, okay, it's currently logging me in. I don't know why it's taking time. Okay, now I'm logged in and saying proceed to Docker desktop. So I'm not logged in. So what you want to do is after logging in, you can now push your image to Docker Hub, basically your account. So our image, my own username is Christopher Sesu slash the name of the image I want to push. So you can basically say Docker push this, and then you hit enter. So once you don't specify the tag, now it defaults to latest. So we have tag 1.0.0, and then we have tag latest. So I did not specify the tag, and then it defaults to latest. So it's now pushing this to Docker Hub. So if I come over to Docker Hub and I see, okay, let's say docker.com. Now Docker Hub will open, and I think I'm already signed in. And if I am not, I will quickly sign in here. And once I'm signed in, it's loading. I don't know. Okay. Okay, I'm automatically signed in. And if I come here, okay, now I have last pushed 1 minute ago. And then if I come over here, I see Christopher says basic node. And if I click on it, this is the general. Still loading. Okay. The repository does not have a description. The repository does not have a category. So the tag is letters. The operating system is Ubuntu. The type is image, and that's not been pulled. So if I want to pull this image, I will just come over here and then copy this thing here. And if I don't specify the tag, it will default to let tests. Then if I come over here and then drop the command and then hit enter, the image will be pulled. So they refer to the do, and then the tag is defaulted to latest. So if I open my browser, go over here and then try to refresh this. Let's say I refresh this, and okay, it's still loading. And then I have tags. I have pulled, last pulled, and then nothing showing here. Let me just see if it's done pulling. Okay, it's now done pulling, and if I refresh it once more, I should see the last pull, except it's not being updated first. Okay, it's not still updated. So this is basically how to push images to your to Docker Hub. First of all, you build an image with a tag. So if you want to build an image with a tag, say Docker build, and then you say -t. That is, you want to attach a tag to this image. And then the tag will have to start with your username on Docker Hub. So my username is Christopher Sesu, and then slash the name of the image. So here I say basic node is the name of the image, and then the tag. If you leave the tag out, it will default to latest, or you can attach a tag 1.2.0, and then where is the Docker file in our correct and in our present or current directory. So if you hit enter, it will use the Docker file in this directory to build this image. And then if you say Docker images, we now have these images, and then we have our basic node. We have a lot of basic node, but then we have tag 1.0.0. We have another one 1.2.0, and then we have the latest. So this is basically how to build images with tags. And as you can clearly see, we are out of time, and I don't think we can be able to cover the Docker file instructions. But what I will do is I will create a table with a comprehensive explanation of this Docker file instructions. And then I'll create a table with this and then paste it on Discord, on our Discord channel for you. And if you have any questions, you can ask, or if it warrants me to create a classroom on Discord, in our Discord channel, so I can discuss this all with you, I will do just that. But I believe we've come to an end of this class and we've understood the basics of Docker. We started with virtual machines, the difference between virtual machines and containers, the benefits of Docker, uses of Docker, the Docker components. We discussed Docker clients and server, Docker images, registries, and containers. We moved over to Docker basics, ensuring the readiness of Docker, running a container, naming a container, starting a stopped container, container logs. We also learned how to log containers on the logs in a container to bring it out and log them on our command line. We did that. We also learned how to delete a container. We learned what Docker images are. you instruct Docker, when you write this work directory here, and then okay. So as I was saying, um, this work directory here, it gives two commands. The first command is make directory, which will create this directory /app. And when it creates this directory, what it does is it's CD, that it changes the directory into this directory it just created. So this work directory, it will create the app directory, and then it will change the working directory to this. So every other command will be executed inside of this directory. And then we'll copy our package.json file inside of this directory we just created, which is the /app. And then we add every other thing. The reason why we're not using copy here is because we are using, the reason why we're using add here is because we want to copy everything. Every other thing, let's say we have 2 files or folders or everything, we will recursively copy those folders with the files inside to this app directory here. So after that, we expose the port of 3000. So this port 3000, if you want to run our image to a container, when you run an image, it becomes a container. So if you run an image, you run 4 instances of that image, it becomes 4 containers of that very image. So when you start a container, the command that will be executed is cmd, which is npm start. Once you start a container, this is the command that will be executed, cmd, and then our app will start. So you can basically expose this. We're saying our app should be accessed using this port, but not on our host machine in the container. So if you want to expose this app on the host machine, you can basically say docker run, or you can say docker start, and then you can specify the port that if you want to say -p, and then you want to forward it to 8080, and then the port in our container is 3000. So what is the name of the container we want to run? We want to run the basic node. Okay, -p. Okay, let's say -- ports. Or not flag -- ports. Okay. I think it should be, is it docker run? It should be docker run -name basic node this. Okay, let's say -p. Okay, -p 8080. And then we'll forward it for 3000 in our container to 8080 on our host machine. And then we'll specify the name of the container, which is a basic node. We want to run this basic node, and then we'll say the image we want to run this container from is a Christopher Sesu / basic node. And we will not specify the tag. The tag should be the letters. And if we hit enter, okay, error response from config, the container name basic node is already being used. Okay, let's change the container name to basic node KC, and then we hit enter. So now our application will run, and then we see it's being executed. Now, if you come over to our browser, here, and then we see localhost 8080. Is it 8080? We're exposing 3000, and then we're trying to forward this 3000 to this port 8080. And we cannot access it here. Okay, that's basically it. We're out of time and we can't fix it right now, but then we'll fix it on our Discord channel. So this is basically it for today. And as I earlier said, we only have 1 day to learn Docker. That's the reason why I have to compress everything into some slides so we can be able to like cover everything. But unfortunately, we were unable to cover everything. So I will try to compile this and then make this more comprehensive and then drop it on the Discord channel so we learn more from these Docker instructions from as run, export, CMD, entry point, and the rest, stop signal, health check. Stop signal, this basically references the signals on our host machine. But basically the signals, Docker emulates the host environment. So the stop signal have the seek10, the seek-int, and all of that. The seek10 gracefully shut down your application. It's processed every other time, then gracefully shut down your application and all of that. So I believe we've understood the basics of Docker, and if anyone out there asks you what Docker is all about, we need to explain and then tell him or her that, okay, this is Docker. Docker is used to create, manage containers, run applications. It helps isolation, portability, and all of that. Okay, so we've come to the end of today's class, and if you have any questions, you can go ahead and ask. And in absence of any other questions, we've come to the end of today's class, and we can call it a day. See you all again on Tuesday, which will be introducing Nest.js. Thank you all.